So we are continuing our lecture on programming, and I actually have opened the example that we worked on last time. So you will give me a color without looking back. No targeting your friend. Give me a color. Green. Go for it. Well, I'm gonna start up. There's a green Creative 40 shirt in the back. So, so I have a matrix here, right? And this matrix has how many rows? How many? It's 2 by 3. So basically this first command, size of A, does what? It tells me what the number of rows and number of columns is, and it stores it in two numbers n and m, so I can use them. And actually, if I decide to change A to something else and something different, this will automatically update, right? And then I proceed to something that has 2 loops, okay? So basically, what am I doing in this first loop versus what am I doing in the second loop? So these are rows, right? 1 through n. Okay. So I'm printing indices just to see how I'm working on these. And then I'm also doing something to element ij. So this is B is ith row, jth element of B becomes 2 times the corresponding element of A plus 1. So this is something that we actually knew as a vectorized way. We knew that in MATLAB I was able to, so if my A, I'm going to quickly go, well, I can just evaluate this. I'm just going to run it. Okay. So my script is called double loop. So if I press run here, it's going to execute. I could also just simply type in double loop in my command line, and either way the script will execute. So now I actually have A in my memory, and B was created as well, but I could have actually created, I'm going to call that B1, as 2 times A plus 1, okay? So this is so-called vectorized way to operate in MATLAB, and this is something that you can write in MATLAB, and you're going to operate on entire array, or 2D array, in this case A, but it's normally not something that you can do in other software. So in other programming languages, and basically you have to write a loop, a double loop like this to access every element. So if you were actually programming in any other programming language, and this is also what MATLAB is doing behind the scene. And it's important, just a moment, let me finish this thought. So it's important to know that just in case you actually have to design something new on your own without having easy tools available. Yes?
How did you get
B1. Okay. So essentially, just to review, basically I first go to the first row, that's my I is equal to 1, and for each column in that row, I will basically just print 1, 2, 3. And I will at the same time operate on each element in that column. So basically my A was 1, 2, 3. And then I will finish. Once I finish the inner loop, my outer loop is still not finished because my I is still small enough. And I have to go up to n. So for I is equal to 2, I will repeat the entire loop. Okay? So I will keep going until I get n. Yes?
Whenever you put in B1 equals 2 times A plus 1, maybe you put a period for every element of it. Is that only between 2 matrices?
So, okay, so yes, that's between 2 matrices. So he's asking, okay, why didn't I put a period? Essentially because 2 is a scalar and not a matrix. Okay, and 1 1 is a scalar. So it's smart enough to add 1 to every element of A and multiply every element of A twice. Again, it's a convenience. I don't know that you can. Yeah, you still can. It still works. So technically, you're doing this. No. So here you would have to actually do identity. So I of size of A. Not no I, ones of size of A. Plus is already element by element, so I don't need a dot. Okay. So it's the same thing. But because it's with scalars, it actually knows what to do. Okay, so this is review of double loops. And of course, if I had a 3D array, such as the porosity and permeability in your homework, you would actually have a triple loop to actually access every element of that array if you wanted to. Okay? Now, where is my next green? Up there, green shirt? Yes, you. So if I wanted to actually sum up all of the elements of A using this loop, what would I do? So in all of these tasks, I need access to every element, which I already have in this double loop. Okay? Now I would just need to initialize a sum at the very beginning. So I'm just going to say S1 or SA, how's that? SA, sum of A, is 0. So this is initialize sum. Okay. And then in order to sum up all of the elements, the moment I access the element, I just need to add it, keep adding it to that sum. Okay? So basically here, inside, pretty much where I define this B or compute B, I could just say SA is my previous sum plus the current element A of ij. So these type of operations, like I'm accessing every element and I'm doing something with it. In this case, it's a very simple thing called a sum. Okay? So the end of the loop, since I accessed every element and added it to the sum, I do have to start from 0, so I do have to initialize. Okay. So now when I execute this, okay, I will also have this SA show up as computed. If I just printed SA is 21. Is 1 plus 2 plus 3 plus 4 plus 5 plus 6 indeed 21? Plus 6, yes it is. So always come up with a small example and check how your procedure is doing. Any questions? Okay. All right, we can then move on because I know you're dying to know what is while loop about. Okay. So while loop, while loop. So sometimes in the case of the computing that sum, it was simple. I gotta access all of the elements of A and compute the sum. Sometimes I want to do, sometimes you want to simply check whether a condition is true and stop computing if certain condition is met. And you might not initially know which elements of A satisfy that condition. So it's actually useful to have a bit of an open-ended situation, and possibly you might be modifying your A on the go and computing something. There's plenty of situations such as those. So if I'm monitoring rainfall, I don't know rainfall in advance, but I know that I want to, stop we had those watering restrictions as an example already in Austin. I want to implement or stop certain watering restrictions depending on what my storage in lakes, Lake Austin, Lake Buchanan, and so forth is, right? So I might have something that is dynamically changing, so I need to actually check on the fly whether the condition is met. So for instance, one small numerical example, not so exciting, is over here. So let's try this example out. Open a script and call it a while loop. And basically start from 1 and then keep dividing your value. First you say x is 1, and at every step you want to divide x by 2. So in first step you're going to be 0.5, in second step you're going to be 0.25. And you want to keep going until your x apparently becomes 0, because we know we can't go indefinitely because of the finite storage ability of my computer memory. So let's see how small we go. Okay? How small of a number does your computer approximate as 0 and cannot store anything smaller? So let's give this a try. Or actually it keeps going. We're going to change this to 0 after a moment. But first actually implement it as this loop. So I'm going to call it while. So syntax is while, and then you have to have a condition, okay? This condition is something that evaluates as a logical true or logical false. So you simply check whether it's true, and if it's true, then you do something. In this case, I simply divide it by 2. And I'm going to just also amend this to store the old value of x before I divide by it. So this is a quick amendment. And I'm going to call it while loop. So again, the syntax is while whatever condition you want to have. Since you're checking a condition on x, you do have to have that x initialized. Okay, it has to exist. Okay, so this is called initialization. And you can have as many commands here as you'd like. There can be a block of commands here that you want to execute. And you put an end when you're done with that block. So it's gonna keep repeating this block of statement as long as this condition is met.
Do you need display x prior to end or for it to work?
If you want to, it doesn't matter. Whether you display or not has nothing to do whether the while loop is work. I'm just displaying it at the very end to see what I got.
But if oh, never mind. Before you have the percent sign, like it won't actually display it correct in the command.
It will not, because I did not. I could have done this, and then it would keep displaying it, right? So either way, I just don't want a lot. It might be 100 times, right? So I don't want to print too many times. All right, let's run this, and I'm actually gonna. Okay. So it says that basically the first time I fell under 0.01, okay, was actually this number. What's my old x? Okay. So one before that was still larger than 0.01, so I didn't execute the loop. Okay. If I'm wondering how many times it did this, well, then I just basically do this and go. So I can. So you can see all of the values as it's going down. So it starts with 0.5, 0.25, 0.125, and so forth. Okay? Okay, so now we will go further. I wanted to just first show a simpler example. So now we will actually say, okay, well, larger than 0. So now we'll actually push it to the smallest possible value. So I first kind of stopped it just before. So display x and also display the old value as well. So let me now run this. Okay. So then this new value became 0 because I couldn't go smaller. And the value just before that, which is one of the smallest, or very close to the smallest value I was dividing by 2. That's kind of a choice. So, but I'm very close to something that is the smallest. I'm on the same order as the smallest value I can represent. Yes?
What did you change to make all the values appear? Yeah.
What did I change?
To make all the values appear from x.
Oh, I just printed. So remove the.
Oh, you
yeah. So this suppresses the output. So let me clear. So if I uncomment it, it's going to print every step. And that's useful when you're looking for mistakes. Yes?
And then is there a way, because before you said, like, oh, you count how many times, like, it divides by 2, is there a way to actually
count how many times?
Yeah.
How do I count? So I will initiate iteration count. It will start by 0. And every time I enter the loop, I'm going to say iteration count is iteration count plus 1.
What is iteration?
It's an iteration count.
Or like how much it produces.
This is iteration 1. Execution of this block of statements is called 1 iteration of this loop. So iteration count, so let's actually execute and see how big is this iteration count. 1075. Or I can just print it here. So no, I don't want them all printed on the screen. The good news is I didn't start the diary, so I don't have 1,000 lines, unnecessary lines in my diary. Is it clear? Start with 0. You gotta initialize, and before starting a loop, you should initialize your values, especially in biology.
Is that at a default value, like after the decimal places we only have 3 or 4 digits with the first one?
Oh, in terms of printing it, yes. So that's just, so there was the way numbers were printed in the first case. So this old x, right? Okay, is printed this way. Now, if I was actually printing it with a finite number of decimal points, let's say old x is equal to 5.6% f, then I would just, oops, wrong. If I was just printing this, I would apparently see only zeros because I printed only a finite number of decimal points. But the number itself is this. Okay? So it can sometimes be deceiving. You see a 0 and you think it's completely 0. If it's perfectly 0, MATLAB will typically just display 0. If it's 0.0000, you can expect that there's more decimal points that you're just not seeing. Okay? So in this case, of course, how would my for loop look like? I would have to go for I is equal to 1 to something, and that would be this iteration count. But do I know how many in advance? No, now I know. Now I'm smart because I saw it, right? But otherwise, I would have to put 1 through 1,000 or 2,000 and like try to do some guesswork to actually see when to stop. And in this case, while loop actually allows me to stop. If I want to count iterations, I can count iterations, but otherwise, while loop allows me to stop. Yes?
What is it that when I ran the while loop, I put a semicolon, but it still ran?
Well, not after the while loop. You have to do it in the program.
Okay.
So, question was, he wrote something like this, and it didn't suppress output. No, you have to actually go inside the loop with all of these commands and put suppress output by typing things within the actual code.
So would you?
So this is not going to do anything. It's just going to execute it. Yes?
What was it that you typed after, sorry, when you got old x equals 5.60.00, etc.?
So if I just printed, so this is that formatted output. The basic floating point, it's not necessarily going to show all of the values because this is now 300, is 300 of them missing, right? About 300 zeros is missing. Now I could probably keep going. Let's try to push this. I don't know if this is going to work. I don't think that you can go through. Oh, yeah, I guess you can. Yeah, it's better to do something. I was just exaggerating. Yes, apparently it printed all of it. Okay. So it can be done. That's the actual number. Okay. If you want a format print of scientific notation, you can do E. And G will print also the better of the two. Okay. So it did actually print 350 decimal points. Sorry, I'm chuckling. I got surprised. I didn't think that it would. I thought it would put a break somewhere. Okay. So this is this formatting your output. So just because you see zeros, that doesn't mean that it's actually 0. Maybe you didn't print enough decimal points. Okay. So these are our loops. So this is just to actually go back to that point. Okay, sometimes you don't want to. While loop seems to be a little more complicated to think about. Okay? You can actually bail yourself out in the same problem with a for loop. So you can actually check whether a condition is met in the for loop, and hopefully that you started enough number of iterations, you can simply break within the for loop if a condition is met. So basically you're using if and formulation. So you can either try to do this example, or you can reformat the one that we had previously. But basically this is going to iterate through 5 elements. And the moment I'm equal to 3, okay, I'm going to break. That means that I'm just going to exit the loop. Or exit this current current command. So basically, it will go through 1, it will print 1 and 2, but at 3, I would break out and I wouldn't print anything afterwards. Okay? So it will just display end of loop at the end. So try typing this in. I'm gonna call it break. So this is just a formatted output for an integer. Okay. So if I execute break loop, my next green shirt is here in the second row. So what will happen if I actually have this printing command before this check? How will the output be different from this? No, end of loop will always print. It's at the very end. It's outside of the loop. That will execute. So let's go and let's think through. For I is equal to 1, I'm going to print. Is this true? It's not true. I can keep going. For I is equal to 2, it's going to print this, right? Is this true? No, it's not, so I'm not going to break. I keep going. For I is equal to 3, am I going to print? Yeah. So it's a small change, but it's something important to note, is that I'm going to break precisely where I'm checking to break, and not sooner, okay? Not later. So I'm going to actually have this printed as well, because I got it printed before I checked whether I is equal to 3. So it's a subtle change, subtle difference, but difference is there. So the moment this condition is meant when you say break, okay, you're going to be done with the loop and you exit the loop completely and continue right after this for loop. If you had an outside loop, if this was a nested loop, you would continue with the outer loop. It would stop only the inner loop. Okay? So it breaks only the loop you're in. So then to go back to the while loop, I could have had a for loop here, having I go to 3,000 or 300,000 or something relatively safe. And then I would, within the loop, check if x is less than or equal to 0, stop, break, and then. So basically, I could have had that check inside. So I could have rewritten this with for loop and a break. Okay? Okay? So that is it for loops. I just want you now to appreciate certain things that MATLAB does for you. Okay? So this is the code that we learned that MATLAB can do. Okay? I define myself an array of values between 0 and 2 pi, going every pi over 30, and then I can just operate on this entire, so sine function will basically compute something for every of these elements 3 times x. Okay? So my vector y will be of the same size as x. If I actually wanted to implement that from scratch without this capability that MATLAB has, and we call this capability vectorization, okay, I'm able to operate on vectors seamlessly, I would actually have to do this, okay? I would have a for loop, okay? And basically I would create my x elements and y elements on the go. Okay? So I would start from 0, because my initial value here would be 0 times dx. Then after that, 1 times dx, 2 times dx, and so forth. So those would be my x's. And then at every time I would also compute the corresponding y, which is sine of 3x. So this vectorization saves me writing this. And it's also much clearer to read. So if you're later going back to the code and looking at what is it doing, it's much easier to see what is it doing if you read this than if you read this. So when testing you, this is still important to know because a lot of programming languages still use this and you cannot avoid it. Okay? So we will be learning both ways so that you're more educated. And I will switch back and forth. When testing you, I will ask you to either use vectorize. So I will basically tell you, you cannot use vectorization, meaning that you have to use for loops. Okay? Or you can, in which case you can do it. Okay. So one thing that is also happening here is that MATLAB has to kind of increase the memory for x and y arrays as it goes. And that is typically inefficient. So if we were actually timing this, this would be a much faster way than this. So MATLAB has basically optimized what to do with this. So it has a whole lot of stuff running behind, making this part more efficient than these for loops. Okay. Also, same thing. We initially learned the vector code of how to refer to matrix columns and rows, right? So basically, if I wanted to just copy the first column of A, I would just say, well, B, first column of B is equal to that of A, and I'm done. Okay? If I had to write a for loop, I would say for I is equal to 1, 2, 3, B of I1 is equal to A of I1. So I would access element by element and copy element by element. So that's what basically MATLAB is doing behind the scenes when you write this. Again, we are referring to this as vectorization. Okay. In general, whatever it is that you're doing, it is a good idea to kind of pre-allocate memory, to tell MATLAB immediately if you plan to use for loops and you grow your array within the for loop. Okay? It's a good idea to simply say, look, my vector will be this large. Okay? And it's not a problem for arrays of 5, of 10, of 20. But if you're going to do 20,000, 100,000, you're going to be much faster if you just tell MATLAB to say, okay, find me a memory for 100,000 numbers in one spot so I can quickly manipulate it. You can think about it as this way. Let's say that you're in a library and you're trying to store 100 books. If you went and found space for 5 by 5 of them, okay, you would first go to one row in the library, find some 5 spots, then you would go to some second row in the library, find the spot for next 5, and keep going. So your books would be scattered all over the library. Same thing if you do that to computers. If you ask for it like little by little by little by little, you keep growing this array little by little, it's it's gonna tuck your array where it can, and then when you want to access all of that memory at once, you're gonna have to run around your library rows, okay, to find all of them, which is inefficient. Preallocated memory says, okay, find the entire shell immediately. Let's put them all in one spot. Does that make sense? Just in computer memory. So it's typically a good programming practice to allocate. And one of those commands that are returning arrays, either a rand or a zeros or ones, we had those built-in MATLAB commands. They can be used to actually simply say, okay, create me an array of that size. The zeros is of course the most popular one. So this basically creates the array of the same size as y and then goes one by one and stores new elements in there. Okay? Finally, we noticed there's one great ability of MATLAB that you can use when creating your functions as well. You notice that we were able to use plot of xy, then plot of xy, and then specify what type of mark I'd like. Or I could even plot two functions at the same time. In all of these cases, I have different number of input arguments. And MATLAB actually has that even if you want to program it, that there's something called an argin, which is a number of arguments input. So you can actually program your code to operate, or your function to operate differently depending on how many arguments it sees passed to the function. So plot function actually says, well, okay, if you don't have any arguments, plot will actually just probably plot an empty figure or something of that sort. Then do something. Otherwise, if your number of arguments is 1, do something else. Otherwise, if your number of arguments is 2, do something third, and keep going. You can keep going like this. So if you're designing your own function and you want it to be able to evaluate different things for different number of inputs depending on what you have, you would basically use this if, elseif, and you would keep checking number of arguments within that if, else. So this is something that can come in handy for designing your code. Likewise, n arguments out, n arg out is actually number of output arguments that you have in the function. So you can manipulate it if you want to. Okay? So this is just for your information if you want to become a better programmer. All right. There is also an ability to make certain variables visible to the entire code. And I'm just going to mention it as a possibility and skip it otherwise because I think it's bad practice. Because you sometimes don't know where you define this global variable, and if you're not aware of it, you might change it inadvertently, and that's not a good idea. So I'm just going to say that this is something that is possible. All right, so let's now actually try to see whether we retained any of this knowledge. And let's actually choose this number 3 and work on it till the rest of the class. I'm going to draw a rectangle around it. Just a moment. No, fell. There we go. So please, number 3. Write a function myProduct.m with loop that will take a vector x. So x is your input argument for your function. And it will compute and also pass this argument as an argument out to the outside world. So it's going to be an output argument, this product. So this again, this is a sign for a product. This is a sign for a sum. You will get to practice these in your homework. And n here is the number of elements in x. And you're also supposed to check if this product is larger than 10,000, then you have to stop the computation. In other words, break from the loop. And Ningyu and I will walk around to help you out with this. So create a new function, call it myProduct.end.